years here in Thessaloniki across different companies. And he will talk to us about how we can use WebAssembly to improve performance. Myself, I'm Evangelia. I just founded my online company since 1 year here from Greece, an online coding academy for our own upskill front-end engineers. But previously, I have been working in Zurich for 10 years at the ETH, which is the Federal Institute of Technology, where I was building mobile apps for NATO training school. I worked for education first. I worked for Swiss FinTech. I have worked for Google for a while as a contractor on the Google Assistant project. Then I worked at the Technopark Zurich, which is a building with 400 startups, where we were an ATA startup, which was a spin-off from the Technical University of Zurich. And then I moved back to Greece 3 years ago, where I worked for Elastic, on the Elastic Cloud department, as a UI engineer on the IM team. And since a year, I took the leap of faith. Yes, please. No. Ξεκινήσαμε, ναι.
Είναι πολύ σκορούτσο.
I did my practice.
Τι έγινε τώρα, πέρασα και το χάλασα.
I didn't say many things about you. You could present about yourself. We have some QR codes on gathering. We are looking for speakers for the next meetups. So far, the meetup is happening every 2 months. With many eyes. Good to see them. We are junior community organizers, that's why. I'm a junior community organizer. Yeah. Is there a free chair for everyone? That's nice. I don't know if it is. Okay, perfect. For the one that just arrived, I just quickly presented the crew here, which is Eleftheria, a front-end developer, which is working recently as a community manager at B2Brains. Georgios, our co-organizer, which is the second speaker for today, a full-stack engineer focused on front-end over the years. Myself, Evangelia, where I have worked for Elastic, for ETH Zurich, for Google for a while, and in London as well as a semantic open link data engineer, and building my own coding academy for front-end engineers. This is my website, which I launched today, and towards the end of this section, I would like to get your feedback as well. I have a separate QR code for the feedback. And we would like to gather new calls, new presentations. We are always on the lookout for speakers. Don't worry, don't be stressed. We don't want fancy topics just with buzzwords. Even the simplest thing that we have in mind could be really valuable for us. So I will share also here on LinkedIn the link. So far, we have agreed to do the meetup every 2 months because it's a new meetup. But as we grow, and if you think do it once a month, we can create a poll and ask you, what do you guys prefer? Do you prefer who prefers once a month? And who prefers every 2 months? There are a lot of one every 3 months is too much. All right. Okay, so let's start with the talks. The first topic is Panagiota.
Can I quickly mention something before that? I take photos and videos and then we upload them on our Instagram. So if anyone has issue with me taking photos, videos, please let me know. So I will take it.
Louder and clear. Did you hear?
No. Okay, I take photos and videos and I upload them on Instagram. So if anyone has issue with me taking photos and stuff like that, let me know. So I will not take your photos. Thank you.
Perfect.
Is it going to be the whole presentation?
Yes. in video, so that you know
Yes.
how to behave.
We also live stream on YouTube, by the way.
We do live streaming now. All right. Okay.
Is there anyone watching?
No, no. What is your stuff? You want to stuff? What is your stuff? You don't think it's always good. Banana fat. This place is not here. I hope it is. Ωραία. You stay here, or give me the link? Λοιπόν, έχουμε πολλά λάπτοπ. Ξέρω από ποια πλευρά είναι όμως. Εκεί πέρα. Και μετά θα έρθουμε. Okay, hello everyone. My name is Panagiota Mitsopoulou. Louder. Sorry? A bit louder, okay. If you don't hear, just say it and I will try my best to speak louder. So my name is Panagiota Mitsopoulou, and I would also like to welcome you to this second meetup. I've been to the first one, but I was not active in this kind of meetups the past 12 years because I was living abroad, and very recently I relocated back to Greece. It's a great opportunity, this kind of meetups, to meet people, and back in the days when I was still in Thessaloniki, I was running to these events, open coffees, meetups, and I met many people, and actually I made some connections which I used to external projects that I was working, and these external projects that I did opened doors for me. So I moved to Prague. I was living there for 2.5 years. I was working for Microsoft, specifically for Skype. So one of the cool projects that my team built was the Skype web client. It was a really great experience. Then I moved to Munich, Germany. So I was working for 9.5 years there in a cool startup. We were 40 different nationalities from all over the world. We built our own browser, a secure browser that was a copy of Firefox with our own anti-tracking, ad blocking, anti-phishing technologies, our own built-in search engine. While I was doing that, I was working also as a mentor in online bootcamp platforms where people from different backgrounds, different ages, they want to do a career change and they just want to get the certification in web development. So I was the mentor there. And the past 4 years, I'm working at Elastic. It's a remote company, 100% remote. I was working in Munich, Elastic, and recently I relocated back to Thessaloniki, Elastic. There are many products. I'm working on Kibana for people who have used the product. Kibana is split in security, observability, enterprise search. So I specifically work at observability. There are also many teams there: logs, infrastructure, APM. There is also LLM team. My team is focusing on alerting, SLOs, synthetic monitoring, and very recently we started using LLM as a use case to do the root cause analysis in possible problems that exist in your system. So I'm not in the LLM team, I'm not an expert in that topic, and that's why I used this opportunity today to give you an intro how to get started as a JavaScript developer with LLMs. So let me present you very quickly the agenda. So I'm going to talk about GenAI and LLMs, a quick intro, just at the base, and then we'll move to some practical examples, an intro to OpenAI, because the best way to learn some new technologies, interacting with the API. I used to show you the example that I will use in my demo with the use of Jypyter Lab. I don't know how many here have experience with machine learning, but when I started my exploration and learning about LLMs, every course, every tutorial was using Jypyter Lab, and I chose to show it to you how to set it up, because it's mainly a Python tool, so we need to do something to make it work for JavaScript. And in the demo time, we are going to build a small app which suggests you some activities that you can do in the city that you live in Thessaloniki. Okay, so let's start with the why, the what, and the how.
why we have today this presentation. Because it's a hot topic, right? So I was thinking, what should I present? And I picked that topic. I'm not an expert there. All of us eventually will need to get started with this technology. So it's a hot topic, and recently I was watching a presentation from Salesforce and layering the 4 different waves of AI. The traditional AI, the generative AI, the agentic AI, and the robotics. We are now in the 3rd wave of this AI world, which means that if we lose this chance to learn now AI, there are many possibilities, not only the companies, but us, the developers, there are many possibilities that we might be out of the game. So we need to get up to speed with the new technologies. So the what is the LLMs that we are going to talk a little bit, use cases, and the how is with the Jypyter lab that I mentioned in the beginning, and the interactive with the OpenAI. So it's not going to be a theoretical presentation, but I just want us to have the base. I have a question for you. How many of you are using in their everyday work Gen AI? Okay, so you are welcome to come here and help me with the presentation. That's great, actually, to see. It's most probably new generation that you grew up learning that technology, whereas us, the older generation, we learned to build everything from scratch. Now the story is very different. So what is Gen AI? Gen AI is a technology that creates text, image, video, based on some input from the user, some prompt. I will tell the difference with the traditional AI in a while. I just want to mention what is an LLM. LLM is a machine learning model that can understand, that can comprehend and understand and give you an answer like in a human language. It's trying to mimic a lot the way the humans think. And LLMs have been trained on trillions of data, and that's how they can make connections, like how the human brain works. You make some connections, it's based on neural networks, and that's how it can propose the answers and generate new text. So the difference with traditional AI, in traditional AI, these systems are trained to do something, some specific jobs with intelligent ways. So let's take the example of an online chess game. So the machine, the computer, knows all the rules, and it can predict the next move based on predefined strategies. This is the traditional AI. You are trained on specific rules, and that's how you make smart decisions. The difference with Gen AI is that Gen AI can generate new text. And the reason it can do that is because of the architecture that is being used. I have a history of LLMs, and the famous paper that was published in 2017, I think, is Attention is All You Need. And it talks about the transformers architecture. So I'm going to mention a little bit about that, I think in 2 slides from now, before we go to the practical part. Okay, so Gen AI and LLMs. We continue that theoretical deep dive. So LLMs take human written instructions and perform tasks as a human. In that picture that I have there, I took it from a course I did on Coursera. I didn't put the reference, but yeah, that's from a course on Coursera about LLMs and Gen AI. In the middle, in the purple circle, you can see the LLM, and the LLM takes an input. That input is called prompt, so I want us to know the terminology. It takes that prompt, and there is a concept of the context window. How much memory, how much space is available to the prompt? Because you're talking to the machine in human language, so you're trying to be descriptive. The way you speak to the ChatGPT is really important. If you don't know how to explain yourself to this new way of interacting, then you're not going to have great results. So this is the context window is how much you can send to the LLM to to predict then your answer, to generate your answer. And the output of the model is called completion, and I mentioned that because we're going to see the OpenAI API, and there is this completion API there. Okay, history of LLMs. I'm not going to say everything here. I'm going to just pick some milestones that are really important. So it looks like it started many years ago. 1967, ELIZA was the first chatbot. It was, I think, created by an MIT researcher, Joseph Reitzbaum, German name, now I don't remember exactly. So that was the first chatbot. It was based on neural networks. I will maybe mention the 1988, that was the current neural networks. They were a bit restrictive because of the size of the data they could use, and later on with 2017, that was like the bang, the big bang, with the transformers architecture. So the two key components of that transformers architecture that changed the whole picture was the ability of the LLM to understand the meaning of the words. There are some terminology there. There is some terminology there about word embeddings and attention mechanism. This presentation today is not about diving into that architecture, but for you, if you are interested, I highly recommend watching a video on YouTube about that. And all the models from 2018 until now, they are based on that transformers architecture and their ability to make sense of the meaning of the words. And GPT, GPT-2, GPT-3, and 2022, it was the release of ChatGPT, and that's when more people, not technical, also I would say non-technical people started using LLM. We are almost done with the LLM background. Some use cases. It's not only the chatbot like ChatGPT and virtual assistants. We can use LLMs for sure. Most of you use it already to create content, to write an essay, maybe your master thesis or something. It's very common to have it generated by ChatGPT. Language translation, summarization, text classification, code generation, GitHub Copilot, and other tools, and entity extraction. We give it a text, for example. My name is Panagiota Mitsopoulou. I studied in University of Macedonia, and I live in Thessaloniki. Entity recognition, it is able to pick like Panagiota Mitsopoulou, University, and Macedonia, and Thessaloniki. So there are many, many use cases. Is anybody from here that is like on the business world, that has like a product, that has built a product that makes use of AI?
I think that front part bit in the backend, but mostly, let's say, chatbots, which take full advantage of any kind of model of LLMs for
like
various kinds of chatbots, not only just question and answer, but
like summarization.
More
agentic. So you make use of that every day, right? Like yes. That's your product, and you try to make use of every possible use case. Like summarization is a very easy way to think about. I have some content, and then I use not ChatGPT, LLM to just summarize the content for me. Okay, great. And that's the last theoretical slide for me that I very recently started diving into the topic. I have heard these words. I just want to make sure that all of us know. Like GPT series is by OpenAI, Gemini by Google, Claude by Anthropic, and it's mainly used for code, right? Code development. My Evangelia, she suggested that to me to start using that for code mainly, and Llama by Meta. So this is just the names so that you have sound knowledge of what is out there.
We have also Let's Chat, the French one recently we had, besides DeepSeek. So Every new day, guys, there is an announcement of a new one. The DeepSeek is the Chinese one that was launched a few weeks ago at a very low cost comparable to OpenAI because it uses OpenAI training. And I heard online that there is the Let's Chat, something like that. The French, or let's say the European stuff. So extra 2 more stuff.
We are going to lose track now, and there are so many. I knew only ChatGPT in the beginning, and that was it. Claude, it was like, what's this? But yeah. Okay, so I'm in this new slide. Let's go to OpenAI. So when I started diving into LLMs, I picked the LLM team at Elastic, and they was like, how should I learn? So some colleagues sent me some videos about the transformers architecture to gain the theoretical knowledge, or to mention like retrieval augmented generation. Another colleague was like, the best way to learn is interacting with the API. So just go to the OpenAI website and try using the API. Okay, so this is like, I don't know if it's visible. The OpenAI expects to receive conversation in a particular format. If you can see here, there is the messages array, which accepts objects with the role and the content properties. The role can be system, user can be also function, and I have an example later in my demo. The system prompt gives like the context. So you give the context of the conversation. That's really important. And the user prompt is exactly what I'm asking LLM to give us back. And you can see here like they use how to make use of that completions. OpenAI chat completions that I mentioned before. That's like the output. Okay, now that's something that I didn't know in the beginning. And today I was asked this question. Someone told me, I have the chat GPT Pro plan. Can I use OpenAI? No, you cannot. You have to pay. There is a different pricing model. If you use chat GPT, it is free. But if you want to you can pay and have the subscription to make use of the Pro feature. With OpenAI, the pricing model is different. You don't pay a monthly subscription, yearly subscription. You pay per API request. So if you make an API request to that OpenAI, you're getting charged. But the cost is very, very small. So when I started doing some tutorials and courses, I was skeptical in the beginning. I was like, I need to pay. I mean, I'm not going to pay. Until I did the course and the instructor told us, hey, you just pay $5. So you can see 5 euros. We are in Europe, so you pay 5 euros and make sure to uncheck the auto charge. And it's very little. Like I'm doing these courses, I'm making use of OpenAI API, and I have 4 euros or dollars, 89.89. So just feel free to buy these 5 credits, and you can make use of that OpenAI to get the experience and play with the API. Okay, so I mentioned function calling, and then we will go to the tool, the Jypyter. Because I have an example in my demo that makes use of that function calling. Function calling enables models to fetch data and take actions. ChatGPT is trained on data in the past. So if you want to give it some personalized information or some recent information, you just need to augment it with some new data. So function calling is one way to that you see, that the retrieval augmented generation is a way to retrieve up-to-date information to send together with your message, and the model will give you back a response based on that API call that you made or some action you can perform, like submitting a form, calling APIs. Okay. Function calling, so let's see how it works. I have an example here. This is the one that we have later on in the demo. And you ask what's the weather in Paris, and you give a function, get weather, that asks an API to give you back the weather, and you send that along with your message. The LLM gives you executes that function because it shows that you have an extra function that you want to give some more context to your answer. It will generate the answer, give you back the temperature, and then in the result, it will get all the previous messages, with the answer from your function call, and the response will actually have the weather in the city that you are right now. Any questions so far? Are we good to go? Okay, so Jypyter. How many of you have used Jypyter so far? It's basically, that's good to see that many of you have used it. It's mainly a tool. It's a web-based interface that is used by data scientists, by machine learning engineers. It's a very quick way to mix code execution, code snippets with text, and get back quickly results, like analyze your data. So machine learning engineers do it all the time. And I wanted to experiment with that. And I started installing it. So there are 3 ways. You can use Anaconda. You can use, if you are familiar with Python, maybe most of you, you can use the Python virtual environment, or there is, of course, an extension, Jypyter extension for Visual Studio Code. So I started installing using the Anaconda. So if you install Anaconda and you want to interact with the terminal, you just open your terminal, you activate that base environment, and you just type Jypyter Lab, and the web browser opens. And that's where you can write your code, your text, and have your example. Alternatively, you can use the navigator, Anaconda navigator. Yeah, so that's the other way. You just use Python. I was using 3.11 because it was failing for something I was doing in -C. So I used that specific version, created a virtual environment with that -n, the end, and the end is the name I just gave to my virtual environment. You can use whatever, and then you need to activate that virtual environment by just typing source bin, the name of your virtual environment being activate, and once you activate that virtual environment, you install Jypyter Lab there, you install Jypyter Lab, and then you can just type Jypyter Lab, and the web-based environment opens. So that's the second way, and there is also that extension on Visual Studio, Jypyter extension. The last point is like select the Jypyter kernel. So by default, Jypyter Lab or Jypyter Notebook, which is like the previous version of Jypyter Lab, has Python. I mean, you just write Python code. But we are JavaScript developers, most of us, so we need to write JavaScript. So what do? There are many ways. I just picked this one. While I was researching, I figured out Dino. I'm not aware about that. That's like an alternative to Node.js, more performant, more recent, and it seems with built-in support for Jypyter. So if I just use Brew on Mac, Brew install Dino, and then all you have to do is Dino Jypyter unstable install. And then once you open your Jypyter Lab, the JavaScript kernel will be there. Okay, so let's go to the demo time. We're going to build a very simple agent in JavaScript. The app will help us find activities in Thessaloniki. Maybe it's party time later on if LLM thinks so. And we will use also that OpenAI function calling that I mentioned. Any questions? Okay, so let's, if I say here.
For the LLM that you mentioned, do you have to pay subscription? How it works?
You don't
It's
have,
not free.
It's not free. You don't pay subscription. You just buy credits. Like you just go to, let me open the browser. No, I want the docs. Yeah, so this is the website, and I will be looking here. It's harder. Okay, there is the billing. You just click that button, add credit balance, and you have the option to just say how much money you want to have. So I just added $5. Looks like it's dollars, and automatically I have access to I have these credits to spend.
How you judge, for instance, whether you will use only ChatGPT or this more advanced LLM?
Okay, yeah. So in the code, you can specify when you use the OpenAI API, Let's go maybe in the... You specify, there is a parameter where you specify the model, GPT-4. And there are some of them that are much, much cheaper. So you just have this option to specify which model you want. But every model that you will use from OpenAI API is not free. You are going to be charged a very small amount, depending, of course, on the model. These models are trained using billions or trillions of parameters. So the more parameters they are trained with, the more expensive it is. But there are also free LLMs. I think Llama is one of them. So there are also alternatives. It's not only the ones that you have to pay, but these are like the more advanced ones that they are trained with trillions of data.
And also, if the information providing after you pay is really reliable, how we can check?
If the information, sorry?
Reliable.
Reliable.
How much? You pay.
They have a pricing model. Yeah, here they maybe make it. They have the pricing model. So, for example, GPT-4 input $2.5, cash input. So you need to study or to just look at this, pricing model, and then the companies will know, what's best for them. But definitely, there is a pricing model for sure. It is a pay per request based on the pricing model. Okay, so let me open now my Anaconda. Sorry. I don't know. Okay, so this is the environment. I could open my terminal and just type Jypyter Lab, but I just wanted to show you that one. It's an application. It's a GUI, graphical user interface. This is a base environment that is activated by default. I was doing another tutorial, so that different environment was created. I'm not going to switch that. I'm going to stay there. All I have to do is just open the Jypyter Lab. So that is Jypyter Lab. There is also Jypyter Notebook, pretty much the same. One is more advanced, like the Jypyter Lab has more features. Like, it's more advanced. I'm going to use this one. So this is now that notebook in Jypyter Lab. You can navigate to the folder you want. So I'm into the demo that I want to show you right now. You can see the ending. The extension here is .ipynb. Yeah. Better?
Yes.
Okay, cool. Yeah, so you can see that ipynb. This is because the Jypyter Notebook or Jypyter Lab was called before IPython Notebook. So the extension is still there because of the previous name of the product. It doesn't mean it supports only Python. That's why they renamed it to Jypyter, to not connect it only with Python. But that concept of kernel, so when you open that Jypyter Lab, the environment opens, and then you can select your kernel. By default, it was Python. So you could start writing Python code, execute it, but I wanted to try JavaScript. So I installed that Dino with Brew, installed Dino, and then I did this, I don't remember, Dino something installed. I have it here. I was playing with another way, some tool, iJavascript, and when I installed that iJavascript thing, I got also that JavaScript, but yeah, I'm going to stick now with Dino since that's what I had in my presentation.
What did you click to open this window? Sorry, I was distracted.
Yeah, by default, and if I never installed Dino in my machine or iJavascript, I would have only Python environment. So I couldn't write any JavaScript code. So this is for me to select the kernel. Okay, so the Dino was already selected. So this is now the app that we are going to build. And this is what I said. It's an environment where you mix code and text. And that's a great way to do a demo by having a notebook and playing the example. So I'm going to play it quick. We're out of time. Okay. Yeah. So as I said, we're going to build an app that gives us the activities in the current location in Thessaloniki. So very quickly, I will go through that. I import the API because I'm in. Let me clear my. Okay. I import the API here, and because I'm in this Jypyter environment, I need to prefix it with npm to be able to use that npm package. So I import the OpenAI module. I need an API key, and that's when I buy the credit in the website. I can create an API key. That's how you make use of OpenAI. You need to have an API key generated there, and that's the one that you need to write here. You don't see it. It's in an environmental variable right now. If I open my Visual Studio, there is this hidden file.env where I have something called OpenAI API key, and there is the value. So I start now running the code step by step. I import the libraries, and I create a new OpenAI. Let's go here. My key is there. Okay, so this is the code that we saw in my presentation. I'm asking now, I'm using the API now, and I will be charged. Like the moment I will call that API, I will be charged, but a very small fraction, 0.00, like it's very, very cheap. I specified the model, the GPT-4o mini, so that I'm charged less, and I use the completions.create, and it expects me to give messages in that specific format, the role system to give the context, and I'm saying, hey, you are a helpful assistant. And the role user, the content is going to be write haiku about recursion in programming. And ChatGPT and these LLMs can be very creative. They write poems, and let's see, endless calls unfold, folding deeper into self, logics, echo things. I don't know. That's what it thinks recursion is. Okay, I'm going to try to ask the LLM, what's the weather in Thessaloniki? I am unable to provide real-time weather updates. For the latest weather information in Thessaloniki, I recommend checking a reliable weather website or app. So now I'm going to use that function calling that I mentioned before. I want to give that information to my model. Hey, I know what's the information by using an API. I know what's the weather. I know my location. I'm going to give you, to the model, I'm going to give you these two functions, and I need to describe to you what these functions do, because LLMs work well with descriptions. Like, you need to be descriptive what it's doing. So this is my function, and we will come to the part where we give it to the LLM. Yeah, so I'm calling my function. Yeah, I'm in Thessaloniki right now. The weather, so I'm just running. Yeah, let's call the weather. Yeah, it gives us back the weather, all the information that we need. And we need now to describe these functions to OpenAI. So there is this concept of tools. The OpenAI expects an array of functions, of type function, and the function, like, we give the name and the description. So we need to describe that this function is for getting the weather in a given location. And then you need to give parameters, if there are any. Like in the get location example, yeah, there are no. Just give me the location based on the IP, like the actual function reads the IP and gives you back the location. So this is like the functions that I'm going to give to the OpenAI. And now I start setting up the messages array. So I'm just writing my logic now. Your helpful assistant only use the functions you have been provided with. And the core logic is in this function where we add the messages. So the input, the user is going to ask, give me activities in that in the city you are. So the input is like the question, give me the activities. So I need to add it to an array so that the LLM has the context, the history of what I asked before, so that it can use that information. So that's the cool part about LLM. They have a history, a memory of the context that your application is having. It's calling that API. Let me, I console log here the response. And let's use that. So where am I located now? And the answer, there is no answer yet, but I'm printing the response. You can see that tool calls object and finish reason tool calls. Why? Because the different thing I did now, I passed these tools to the API. And now the LLM will take into consideration these tools because I described that the weather, and now I'm asking, or the location, what's the location, or like, where am I located now? And it knows that I have something that might be useful. And then writing my logic, I'm not going to go into great detail about that. So I'm doing my mapping these functions to we have the name of the functions and we need to translate them into a function call. I'm running that. And now I updated my function to take into consideration that finish reason field. So if it's tool calls, then it knows that, hey, I need to map it because it was get location and I have that available tools get location. It's going to use that JavaScript code to just get the call that it needs to call. So it knows that, hey, I need to call get location now because I'm asking something about the location. So I have that information. I can answer. So where am I located right now? Thessaloniki, and at the end, I'm going to ask, suggest some activities based on my location, and I get back the weather. So still, it didn't finish because it has some information about the weather. So I need to adapt a little bit my logic. So now it's like a logic problem, right? You need to adapt your code so that it keeps asking the LLM and checking. It does actually a loop and keeps checking the finish reason, and only when it's stopped at some point, it will read the get location, the get weather, and it will be able to answer back to me, and I'll just run it. And you are currently located in Thessaloniki. The weather is quite chilly, these temperatures, and yeah, we can visit museums, historical sites, shopping, indoor markets, spa day. Yeah, so the LLM thinks that we should go and have a spa right now. But yeah, so that was the presentation. Do you have any questions? Yeah.
The actual function call of a tool is happening here in Jypyter Notebooks. You
Yes.
didn't pass function definition, and it's happening on OpenAI's backend.
No, that's true. The function call happens here on my code. So I am responsible for knowing the API. I know that API depends something called function calls, finish reason, tool calls, or whatever. Yeah, so that's happening on my side, on my business logic, or that repetition that I did. It's not like OpenAI, and that's a tutorial that maybe I can close with that. And they mentioned that thing, so that's a very good question. So I chose just to show you an existing tutorial from the OpenAI website. And they mentioned that it's not the OpenAI that calls your function, it's you. You know the API, what it tells, and you make use of that and write your logic. But yeah.
So we're responsible to wrap the responses with some small logic that we can make the calls.
Exactly. You have the logic to know where to stop, asking again the LLM. It has this messages array, and then at some point you look through that, and okay, when the finish reason is stopped, then don't ask anymore the LLM. Yeah, so it kind of asks the LLM 2-3 times, get the weather, get the location, and in the end, yeah. So it's our logic that takes care of calling whatever it needs to call.
Okay.
One more question?
Why do we need to pass the tools call logic after the available tool? Since we have already passed the description of the tool and the signature that it's waiting for. I expect it to be smart and call the correct signature, matching description, with the correct parameters. But it needs some extra information.
Exactly. Yeah, so that's what I read also in that tutorial, that it's asked that the OpenAI is not calling. Let me see if At this point, it's important to understand that OpenAI doesn't execute. Sorry? Yeah. Okay, at this point, it's important to understand that OpenAI doesn't execute any code for you. It just tells your app which functions it should use in a given scenario, and then leaves it up to your app to invoke them. I understand what you say. You would like it to be smarter so that you make the API call and it kind of goes through all these function calls behind the scenes because you say, I give you the function calls. But it turns out that that's how the API works. It will give you back the... if you play with that example and you console log the response is, I started doing the same. I was asking, what's the weather, or only give me activities. And I was seeing that it was calling, for example, the get weather. And then I was like, okay, I want more, like the location. So it looks like you just need to have that logic in your code.
One follow-up. So if it doesn't execute any code, and let's say I would like to base the answer on the weather answer. So let's say I would have 3 steps. I will need to create like a forward iterations in order for it to go and execute more and more and more.
It looks like you need to have your logic there. And do what your business is wants you to do.
It's just matching descriptions to
nothing more. And I searched, like, that's my last comment, like, why should I use function calling? And the answer from the website was like, it's a nightmare for developers to have to deal with unstructured text, like strings. Because developers are used to have structured outputs. And with this function calling, you kind of, imagine we didn't have function calling, we would need to use regex or prompt engineering, but with function calling, you kind of give it more structure to what you expected to have, something like that. And you have more consistent outputs with function calling. Otherwise, if you make the same call to an LLM, with a little bit different input, you will be getting every time different results, and that's really annoying. So with function calling, you can achieve these consistent results, these consistent outputs. Thank you, Panagiota. Okay, thank you.
We can have workshops in the future, more elaborate on this kind of stuff. We welcome our second speaker, which is Georgios.
Hello.
Take, the floor is yours.
Yeah, give me a second. Okay. Full screen αυτό. Θέλω να πω full screen μας. New full screen. Okay. Ναι. Πού να κάτσω. Καλύτερα θα κάτσω. Ναι. Εδώ. Okay. I'm gonna be seated if it's okay. So, okay. My name is George. It's okay. It's okay. Yeah, my name is George. For the last 7-8 years, I work as a front-end engineer here in Thessaloniki at BetAdvanced. I don't use WebAssembly on production. It's my first time I dive into this topic. So it's going to be an introductory talk. And I think it's useful, especially nowadays we need performance in our web applications. So it's something very hot and it's growing. The name of the talk is The Power of WebAssembly. and why we, as JavaScript developers, should care. As we all know, JavaScript is fast, but sometimes that's not enough. There are some applications that need to execute high-performance CPU tasks, and in these cases, JavaScript is not enough. That's why we need to use WebAssembly, which is a binary instruction format. We can use any language, any low-level language, and we can compile to WebAssembly and execute on the web, directly on the web. And we can achieve real near native execution speeds. In this talk, we're going to cover why WebAssembly is a game changer, how it works and where we can use it, some real-world use cases from applications, from real applications, and maybe some challenges and limitations we may face. And at the end, I'm going to show you a hands-on demo of WebAssembly in action with React and WebAssembly, how we can integrate React and WebAssembly together. Before we dive into WebAssembly, we are going to talk why web performance matters. Users nowadays expect fast and smooth and responsive web apps, even if it's a social media platform, an online game, an online editor, image editor, anything. Speed is the key. So, as we said, JavaScript is great, but sometimes for CPU-heavy operations like rendering 3D graphics, processing large datasets, or running machine learning models on the web, image video processing, cryptographic calculation, etc., JavaScript may be very slow. So, in these cases, we're going to use WebAssembly. The main advantages of WebAssembly are the following. It offers fast load times and execution. That's why, because it's compiled, and the bundle size is much smaller compared to JavaScript. JavaScript's files are bigger, and the load time is slower, of course, and binary format means it's closer to machine code, so it's easier to execute because we don't need to parse and interpret the code like we do with JavaScript, like browser does with JavaScript. It also offers language diversity. Developers can write in almost all low-level languages like C, C++, Rust, maybe Go, even Python, and many more. So yeah, we can leverage all the libraries and the ecosystem of other languages and use them in the web. It also offers improved security because it runs on executed on a sandbox environment, and it prevents unauthorized access to system files, system resources, making very secure. Lastly, it offers near native performance. As we said, it's close to machine code, so achieves near native execution speeds, and it's ideal for the tasks, heavy tasks. Now, how it works? We pick any language we want, like C++, Go, Rust, and after that, we need to compile the code to a WASM module, WebAssembly module. To do that, we need a compiler. Every language offers a compiler. For example, C has Emscripten and Rust has Rust-C. The WebAssembly file can be loaded later on the browser. It's in binary format, and optimized. Then we have to load this file from the browser using JavaScript. So in order to integrate with WebAssembly file, we need to fetch it using an HTTP request. And browser offers APIs, high-level APIs, to instantiate and load the module, the WebAssembly module. And we can expose some functions from the low-level, from the WebAssembly module. And the exported function can be used directly in the browser. Finally, we have the execution. WebAssembly runs in its own sandbox environment, has its own memory, so it ensures security. And we can call functions, allocate memory, use global variables. We cannot directly access the DOM. We need to use messages in order to communicate with the DOM. So that's the way WebAssembly communicates with JavaScript. But we can run a function and get the output. So how it looks like. This is a Rust code, the source code. There's also the WebAssembly text format, which is a human-readable format, can be read by humans. Of course, it's close to assembly. It's like assembly. And finally, we have the WebAssembly binary format, which is the final output. But all browsers in their dev tools, they support the conversion of WebAssembly binary format to WebAssembly text format. So when we fetch a WebAssembly module, you can also see the text format. So this is for debugging purposes. It's okay. Debugging it's hard. It's not that easy, but yeah.
So you say it's human understandable.
Yeah.
You can understand that. I mean,
you can understand. Yeah. It's yeah. It's not very understandable, but it's better than this, I guess.
But this is challenge. It's just like metadata for debugging, as you said, right?
Yeah. I'm not sure if you can add breakpoints. I'm not sure, but it's kind of readable, I think. Okay. So when we compile with a compiler, usually compilers produce a pair of the WebAssembly module and the JavaScript module. The JavaScript module is used to integrate with the WebAssembly module. We can do this with ourselves, but it's a little bit difficult to handle all cases. So in order to focus on writing code, compilers produce this JS file and simplifies initialization and interaction. More specifically, we don't have to worry about environment detection because WebAssembly can run on the web, but also can run on Node.js, web workers, etc. We don't have to handle errors. Error handling is handled by this file. And we also have the callbacks, which are very useful, pre-run hooks, init hooks, post-run hooks. So we can properly set up and use cleanup logic, etc. And of course, we can access the memory of WebAssembly, which is separated. That's all with the JS file. So yeah, this is a comparison between the sandbox, the WebAssembly sandbox and the JS environment. So with the WebAssembly sandbox, we cannot directly access system resources, file system, hardware, the system memory, nothing, unless something is exposed via JavaScript API. JavaScript, on the other hand, also cannot directly access system resources, but has access to high-level browser APIs like DOM and local storage, session storage, etc. WebAssembly has its own memory space and managed by WebAssembly, cannot access by JavaScript directly, cannot access, JavaScript heap directly. As we said, no direct access to DOM. On the other hand, JavaScript can direct access and manipulate the DOM, of course. What else we have? I remember, sorry. Strong isolation, memory access is restricted. I don't remember that, sorry. I'm gonna move. We have some real-world use cases in these categories, like design and editing, gaming, image and video processing, cryptographic and blockchain, 3D and mapping, and AI and machine learning. The most well-known applications are Figma, which is high-performance collaborative design tool, Unity and Unreal Engine to develop games, the Adobe Photoshop on the web, which offers image editing directly on the web with near-native speed. We also have Google Earth, which has 3D map rendering, and other apps like TensorFlow, which can run machine learning models efficiently. And then we have some challenges and limitations. Not all browsers support the latest features of WebAssembly. Most modern browsers support WebAssembly, but some older versions of browsers and maybe some mobile browsers may lack of full compatibility. Then, as we said, WebAssembly uses a separate memory model, so it's sometimes difficult to deal with memory. We have to manually allocate and free memory, and this can be less flexible compared to JavaScript memory management, which is high level and offers garbage collection. And then debugging also can be tricky, especially for low-level languages. Finally, the ecosystem is still relatively new compared to JavaScript, and we may have issues when we want to integrate WebAssembly to bigger and complex projects. That's all I have from theoretical. And then I have a demo. Source code is here if someone wants it later. And I'm going to show you the demo. So, can we see? No.
Light mode.
We need to turn off the lights, maybe.
I cannot use light mode. Zoom more. One more zoom. It's going to be difficult to navigate with, but okay. I don't think I can. Now you can see better? Oh, give me a second. Βρήκαμε τίποτα? Όχι. Κάπου πίσω έχει. Λιτζά. Έχει και ένα πάνελ. Το πάνελ, αλλά δεν ξέρω τι θα κλείσεις άμα το κλείσεις. Ή κλείσεις και Wi-Fi και τέτοια. Ναι, μπορεί να κλείσει όλο το ρεύμα. Okay. So we have the source code in C, good old C. Some filter functions for images, like grayscale, invert, blur, etc. And if we want to compile this code, first, we can use the mscripten. I also have a Docker file, so we don't need to install any dependencies. We can use the mscripten Docker image, copy our files, run the make file, and then copy the output to the Node application and run the React app. It's simple. So how it works? We give the input, which is the source code. We give the output. The output is the JS file, not the WASM file. It also produces a WASM file with the same name. Here is the WASM file produced, binary. And here is the image filter, which makes the integration. We also define the exported functions one by one, grayscale, sepia, invert, blur. And I also expose malloc and free to allocate memory. We also have the exported runtime methods ccall and crap. Crap is used to wrap a function and define the typings, makes mapping between types. For example, because we don't have pointers in JavaScript, we have to define number, and number for image, width, and height, because this is an address in memory. That's how it works, the crap. And finally, I use the export ES6, which helps me to have a ECMAScript module, because another way, it's going to be a common JS module, and you cannot import it in modern applications. That's the script, the compilation process. So then, let's go to the React app. The React app is nothing special, just a form. We can upload an input file, image. We also select the filter. I defined the filters here, so better. Nice. It's okay, yeah. So we have the filters here, grayscale, sepia, invert, and blur. The select input. We select the filter. We upload the image, and we have a use effect here. And when something changes, so the image or the filter, if we have the image, we're going to process it. So all the work is here in the process image function. Before that, we use Canvas to create an image, draw an image, and then return back to and render it to the view. But all the work is in the process image function, which take a filter function, the data, the width, and the height. The data is a uint8 clamped array. The clamped array accepts value from 0 to 255 for colors, because you cannot, the black is 0 and the white is 255. So we have this type of array, width and height in the filter function. And I have this helper function, which loads the module. This is how the module is loaded lazily. I also cache it in the memory, so I don't make requests all the time. We import it lazily with the import function. The module is imported here, and we also can define here the hooks, pre-run, post-run, on runtime initialized, and then use the C-wrap to define the functions. Here are the functions: grayscale, sepia, invert. All functions have the same signature. They take 3 arguments type of number, and they return nothing. It's a void, because the C function directly mutates the image on memory. It does not produce a new array. So yeah, now we have the module loaded, and the filters function, functions. So when we go back, we can allocate memory. Data length is the length of the array, so that's how much memory we allocate. And the buffer is the number, the address in the memory. We can also use the heap U8, which is the memory, in the heap memory of the WebAssembly module. So we set there our data, starting from there, from the buffer. We call the function from JavaScript. So this is where magic happens. And we return back here the output. We get the output. To get the output, we again use the memory, because after the function called, everything from the array is changed. Finally, we free the memory, and we get back the output. That's how it works. And if we can see it in action, we can choose a file, upload it, and here we have grayscale. If we change, we have invert and blur and sepia. So I think that's all. That's how it works. Any questions? Okay.
In the beginning, I think you showed us a command that you ran, and you specified some functions that you exposed.
Yeah.
In which part of the code was that mapping? Like, you had some grades?
Yeah.
The filters?
Yeah, here.
Okay.
We use the C-wrap. We can also use _grayscale, WASM module dot underscore grayscale, but it's better practice to use C-wrap, as far as I know.
So that's the part that does this.
Yeah.
That is exposed.
Because I also exported
this one.
function, you could use it, but I think that offers also error handling and the typing. Thank you.
Ευχαριστούμε τα φώτα. Δεν είναι σημαντικά, παιδιά, κάποιες ανακοινώσεις να κάνουμε. We have some small announcements. You can have your QR codes ready if you want. So the Athens JS meetup, which is called Greece JS, I don't know if you know it. They have already over 3,000 members. I am contacting with the folks, they are the organizers, and they are looking for participants to give talks. So I'm going to share with you the barcode, which is the call for proposals for the Greece JS in Athens. If any one of you is interested in giving a talk. One sec. I have 3 announcements in total. All right. So if you want, you can screen, first of all, This is for us, for the SKJ, JS Meetup. You can QR code it. We are looking for nice inclination of the projectorization. Logistics. Can you? Nice. So this is the QR code for our meetup. It will take place in 2 months, and we don't have any speakers yet. So we start from now collecting you. Don't be stressed. Don't be shy. You saw how nice it was tonight. But even if it's something simpler, we don't mind. I mean, we want to hear anything seriously. And just feel free. You can even come with your pajamas. I want you to feel comfortable and not be shy when presenting. But if you have something really difficult and interesting to share with us, we're also open to that. So this is the Greece JS. This is the Athens Javascript Meetup, the oldest in the country, with above 3,000 members. They are also looking for speakers. And I have one more announcement. As you know, I've been living in Zurich for many years, so I still have my contacts in my life there. So I have some news for you. The next business person from my business network there, they are looking for a part-time full-stack developer. They are a startup on the HR industry. They are building an HR product. Currently, they are really early stage startup. That's why it's only on equity basis, and it's part-time full-stack engineer with, of course, a salary on top of the equity as soon as the first client will be there. So if you have a job, whatever, but if you want to invest in your future with equity and potential salary, of course, but not for now, so I'm transparent about that, please reach out to me, and I will discuss with my colleague back in Zurich. So this is also an opportunity for you. And I will be happy to bridge the gap between the two countries. So this is for today. Thank you all for coming here. Yeah, that was it. And I want to thank both of you. This is really great. I mean, this is brilliant. Both of you. Yeah.
I have a question. Would you be more interested into having like workshops instead of talks? Like when I was in Munich and I was attending some meetups there, like they were about testing. And we were doing some workshops, like hands-on, we were bringing our laptops, like if you would think that
would you be interested? Yeah.
Better?
Yeah.
Yeah, like more interactive.
Nice. We want your feedback as well. So
I would like that.
We want to grow and improve because we just started. And I think the
You share the feedback form.
And we also have the feedback form. Yes, please. We want to improve there.
Any
we also
comments?
learning to be community builders.
Any comments are welcome, of course. Any comments are welcome.
Any comments are welcome. And I know the QA tasting meetup here in the city, which is an old one. They do workshops all the time. Yeah, exactly. Yeah.
Yeah,
So
we can do hackathons or coding.
Hands-on, or we can even have sometimes small 5-side chats, like 5-10 minutes each one of you discussing on a topic that we have predefined. I mean, we can explore different options. Yeah. Feel free.
Will you upload these slides?
Yes, we will upload them. Let's see where is the best place so that it's centralized. On,
Do you have a Discord server? Discord server.
No?
You should get that.
Yeah.
All right. We'll discuss.
And
For
I
sure,
think,
we will upload them.
I
Yeah.
think it's better next time on live stream to use Google Meet to share the presentation, because people wanted to see the slides.
All right. Okay.
And also use dark better. The white was difficult to see.
All right. Okay. Okay. Thank you. Thank you. Thank you, guys.
Thank you. And there are pizzas.
The most important part. Pizzas have arrived. Yeah.